So we're looking at where functions meet. So for this exercise, we're only dealing with a quadratic and a line. All right, so if you think there's three circumstances in which that could occur. So if you have a line, it could cut the quadratic. All right, and that means it's going to cut it in two spaces. First it has to cut it there, and then it has to cut it there. All right, so that's called cutting it. We've got the equation of a line, y equals mx plus c. The equation of a quadratic, it's going to cut it twice. It could be that it just touches it, just touches the edge of it. And in this circumstance, we call that tangent. Okay, that the line is tangent to the curve. So a tangent is a line that is parallel to the curve at that point and just touches it. And then it could be that they don't touch at all, that they don't meet ever. So they're the three circumstances in which a line and a quadratic might possibly meet. So here we need to find the point of intersection between f of x and g of x. So we're going to do it manually first, and then we'll use technology to help us. The way we do this is it's going to happen when f of x equals g of x. So that means when x squared take 5x plus 6 equals 2x take 4. It's when they're equal to 1 over. We're just going to solve for x. All right, so what we're going to do, move everything over this side. So I'm going to get x squared take 5x plus 6, and then I'm going to take 2x and plus 4. And that will be equal to 0. Just moved everything on the right over to the left. Let's collect like terms. That should have an x. We're going to have x squared take 7x and plus 10. And now we need to solve this by factorising. So x and x, multiples of 10, minus 5 and minus 2 will generate our solution. Give us minus 7x. So we've got x take 5 times x take 2 is 0. That means x is equal to 2 or x is equal to 5. So these functions are going to meet in two spots, when x is 2 or when x is 5. Now, it said find the point of intersection. All right, so we've found one of the coordinates, we've found the x, but we need the corresponding y coordinates. We need to know the y value when x is 2 and when x is 5. Now to find the y value, you just have to go, oh, when x is 2, what is the value of y? And put it into this function. Or this function. It doesn't matter because they have the same x value, they're going to have the same y value because that's where they're meeting. So which ones are going to be easier to put it in? The line. Heaps less working out involved. So we're going to find g of 2. All right, when x is 2, that would be 2 times 2 take 4. 4 take 4 is 0. And we're going to find g of 5. That's going to be 2 times 5 take 4. 10 take 4 is 6. So the two coordinates where the functions meet, we've got x is 2, y is 0, and x is 5, y is 6. Let's do it on the calculator. I'm going to go into graph mode, and I'm going to graph in y1.
I need to move the board for the camera.
Squared, doesn't matter. If you want, if it can reach it. X squared take 5x plus 6. Okay, that's going to be my y1. And then y2 is going to be the equation of the line. And I'll get you to follow along here with your calculator. The equation of the line is 2x take 4. Let's graph that with a standard V window. All right, beautiful. 2 points of intersection. And the calculator can even tell you the coordinates of them. If we press G-solve, G-solve brings up all the possible options, and we're looking for intersection. That's F5. Look, it tells us when x is 2, y is 0. That's the first one. And then we press the across arrow, it's going to give us the second one. X is 5, y is 6. Okay. So that's what question 1's like, and that's reasonably okay. All right, that's just combining a number of different mathematical processes we've already learned. Question 6, the next part we're going to do together is going to really escalate. So pay attention, okay, but feel affirmed that you can do this. And then when we get to that next part, maybe it's something we can spend a bit more time honing our skills on. So the next question says, find the values of m for which x squared take 2x take 3, for y equals x squared take 2x take 3, and y equals mx take 7 has one point of intersection. So if they're going to have one point of intersection, that means it's tangent. That's what it means, isn't it? So they're asking us for this circumstance specifically. Not this circumstance specifically, not this one. So, we're just going to do it like we were doing. Well, if there's a point of intersection, it's going to occur when the functions equal one another. So we've got x squared take 2x take 3 equals mx take 7. Alright, so that's all fine so far. We're just treating m as a number. Move everything to the left. Take mx plus 7. Alright, and I'm going to write these two terms next to each other. Okay, I'm just going to rearrange it. We can collect the numbers because they collect. But I'm just going to write it like this. Now minus 3 plus 7 will be plus 4. So here we can write this like this. All right. So we've got 2 and m, 2 plus m, and if you were to expand that, you're going to get minus 2x and minus m x. All right, so that negative applies to both of them, and x applies to both of them as well. So that's probably one of the tricky things, but the reason we're doing that, I'll show you in a moment. And then we have plus 4 equals 0. All right, so that's okay. Let's jump back over here for a second. We're going to have 2 points of intersection when the discriminant is greater than 0. We're going to have 1 point of intersection when the discriminant equals 0, and no points when the discriminant is less than 0. All right, that's once we've combined everything. This quadratic is going to have 2 points of intersection when the discriminant is greater than 0, 1 point when the discriminant equals 0, and no points when the discriminant is less than 0. So that means we're going to find the discriminant of this quadratic. Okay, so I think we're sort of okay so far. That was perhaps a little bit hairy, but let's have a look at the next part. We just need to find the discriminant. Now remember, delta is b squared take 4ac. Our value of a is 1. Our value of b is minus 2 plus m. And our value of c is 4. Okay, remember, coefficient of x squared. Coefficient of x is that whole thing there. That whole thing is our value of b. 2 plus m, and c. So now we're just going to find the discriminant using these values here. So it's going to be minus 2 plus m squared. Take 4 times 1 times 4. Yeah, excuse me, it's b squared, and the value of b is negative. Alright? So we've got b squared take 4ac, and now we're just going to expand that and collect like terms and try and simplify it a little bit. So here we've got this thing in brackets, it's got a negative there and it's squared, so the negative is just going to disappear. And we're using the perfect square rule for this. 2 plus m squared, that's going to be 4 plus 4m plus m squared. Okay, a squared plus 2ab plus b squared. Perfect square expansion. And then we've got over here, take 4 times 1 times 4, take 16. All right, that's the discriminant. We can collect that a bit because we've got 4 and minus 16. And I'm going to write it as I would a quadratic in order. So we've got m squared at the front plus 4m, and 4 take 16 is minus 12. So we've found an expression for the discriminant in terms of m. All right. Now I said 2 points of intersection when the discriminant is greater than 0, 1 point of intersection when the discriminant equals 0. This is our discriminant. Let's make it equal to 0 and find the values of m that make it true. So I'll just rub this out so I can use the space here. So we've got m squared plus 4m take 12 equals 0. Okay, another quadratic. This time it's not with x, it's with m. And we're trying to factorise. -2 and +6. Alright, so we're going to have -2m plus 6m gives us +4m. So that's our solution. And so we've got when m is equal to 2 and when m is equal to -6, there is one point of intersection. So let's look at that graphically, because that's important. So the first quadratic we're dealing with is this one. And then the two lines are the two values of m. 2x takes 7 or y equals -6x takes 7. Remember, that's what we found. We found that value of m. So let's put all three of those equations in. We're going to put in x squared, take 2x, take 3. We're going to put in, what's the first one? 2x take 7. And -6x take 7. Okay, have a look at this beauty. Okay, so we can see it's touching there. Okay, that's the one point of intersection there. And then it's also touching up here. That's the one point of intersection there. So there are two values for m for which there is one point of intersection. So yeah, that's a pretty tricky question. All right, that's sort of 5-6 mark question. So what do? Like, we don't know this value here. We're trying to find that value for a given solution. All right, the given solution is one point of intersection. And so we make them equal, we bring it across, collect it. Now we've expressed it as a quadratic, and we say, what is the discriminant of that quadratic? Because the discriminant is going to allow us to generate the solution we're after. If it was asking for two roots, it's going to be when the discriminant is greater than 0. It's asking for just one point of intersection, so that's the solution we're looking for. We've found the discriminant, we make it equal to 0. These are the values of m that make the discriminant 0. And so we've graphed it, we can see they're the 2 points that are tangent on the graph. So look, I think we found that first point okay. So start with like doing 4 of them, and then just see how you go with these questions, okay? Because they will be a bit challenging. All right, so I reckon get started on this. Don't stick around with 2E.